Do you know how to determine the correct size of a current protection device? Whether you are an apprentice, a homeowner, a contractor, an inspector, a seasoned electrician, this is a topic you need to master in order to stay code compliant, protect people, and stay safe. Let's get into it. Hey everyone, welcome back to the channel. My name is Alban. I'm electrical engineer working in compliance industry, here to make the electrical code simple and practical for you. Little disclaimer, this channel is not linked to the company I work for. Today we are diving into how to determine the correct size of a current protection device, or OCPG, using the electrical code. For example, you might use the Canadian Electrical Code, or CEC Part 1. What is OCPG, or Overcurrent Protection Device? An overcurrent protection device is a device like fuse or circuit breaker that protect your wires and equipment from drawing more current that they are designed to handle, preventing fires, shock, and damage. There are three types of overcurrent that can happen in a circuit. It can be an overload, a short circuit, or a ground fault. And the OCPG, or the overcurrent protection device, must be sized to handle them appropriately. In the Canadian Electrical Code, for example, the size of the overcurrent protection device must not exceed the ampacity of the conductor that they protect, unless otherwise permitted. For example, if you are using a wire rated 20 amps, you cannot use a circuit breaker or fuse rated 30 amps, unless the exception applies. So how do you determine the correct size? In order to do that, you have to follow these three steps. Step 1, determine the load. So start by calculating the total connected load in that circuit by using the data sheet, the nameplate, or perform a load calculation according to the standard that you are following. For example, if you have a water heater rated at 4500 watt at 240 volt, that water heater will draw 18.75 amps. Step 2, apply the conductor ampacity. Depending on the jurisdiction that you might need to use some corrector factor to apply before choosing the conductor. In the Canadian Electrical Code, for example, we have the 125% rule for continuous load. So for a water heater which draws 18.75 amps, if we apply the 125%, we will be around 23.4 amps. That means that in the Canadian Electrical Code, we will probably choose a 10 AWG copper conductor with 30 amps rating. Step 3, choose the overcurrent protection device. If you remember, we were saying at the beginning of this video that the size of, according to the Canadian Electrical Code, the size, for example, for the Canadian Electrical Code, the size of the overcurrent protection device must not exceed the ampacity of the conductor. In this case, we have chosen a 10 AWG with 30 amps rating. This means that the size of the overcurrent protection device that we will choose, in this case, if we follow the CEC Part 1, that means the Canadian Electrical Code, the size of that overcurrent protection device will be also 30 amps. Now you know how to determine the correct size of the overcurrent protection device, but there are exceptions. So in bonus, I will give you common exceptions. So now you know how to determine the correct size of overcurrent protection device, but there are exceptions. Equipment like transformers, motors, HVAC have a particular way to determine the correct size of the overcurrent protection device. In some case, you have to follow the standard, maybe the standard in your jurisdictions, or you have also to follow, for the case of the HVAC and appliances, you have to follow sometimes the manufacturer instruction manual and the electrical code. So refer to your electrical code or to your standard to determine the correct size of the overcurrent protection device. To wrap up, or in summary, you have to know, one, you have to know your load to choose the correct size of an overcurrent protection device. Two, you have to choose the conductor. And three, you have to match your overcurrent protection device to the ampacity of your conductor per the rule of your jurisdiction. For Canadian, for example, always check the latest version of your electrical code, and in case of doubt, please consult the authority having jurisdiction in your area. For Canada and in Ontario, we know that I think the authority having jurisdiction is ESA. Find this helpful? Don't forget to like, subscribe, and drop your questions in the comments.